Welcome to the first video for September the 11th and September the 12th. This is the video about counting significant figures. Your essential question: when are zeros not significant? By the end of this video, you should be able to answer that question. So first of all, let's talk about what is significant figures. Why do we need those? The definition for significant figures is the digits of any number of which you are certain. So if you are taking a measurement of something, let's say that you have a burette and you are measuring a volume with your burette. The level of precision of the burette gives you one amount of certainty. You cannot say what the measurement is beyond that level of certainty. For example, if the burette tells you that it is 32.6 milliliters, now you are allowed to estimate one more digit, so you can be certain of that. So let's say that you are 32.65 milliliters with certainty. That's all you know about the measurement. You can't tell me anything about the thousandth place or the 10,000th place or anything like that. So you have to be clear how much precision is your instrument giving you, plus the estimation place. Those are called significant digits. These would be significant. So who are significant digits? When you're looking at a number that you haven't measured, but you know it's been measured, you have to know, if I'm looking at this number, what's significant about this number and what's not significant. Significant numbers only play a role when you measure something. Any number that hasn't been measured, don't worry about its significance. When you measure, you have to worry about significance. So numbers that are significant, always. All digits 1 through 9. Basically, if you're bothering to tell me that this is a 3, then you know it's a 3. The only digit which is only sometimes significant is 0. And that's why the question is, when are zeros not significant? So if these are always significant, these are sometimes significant, when's a 0 significant, when is it not significant? The reason that zeros are different from 1 through 9 is that zeros have two jobs. In some cases, they have a meaning. They mean nothing. There's nothing here. In other cases, they're just placeholders because of the way that we do our numbers. Whenever a 0 is a placeholder, it's not significant. It's just there to push the numbers into whatever position on the number line they're supposed to be. But if the 0 is actually representing nothing, then it is significant. Let me explain. We have what you call the left and right rules. The right rules mean that if there is no decimal in the number, you read the number from right to left, you count your significant figures after you hit a number 1 through 9, and then you keep counting after that. So let's try this example problem. So we have 101,100,000. How much of this is significant? How much of this are we certain? We read from the right to the left because we do not see any decimals. So here's the right end of that number. The first number we get to is a 0. What's the job of this 0? Oh, it's just there to push these numbers over so that they don't start at the ones, they start over there. So this one is not significant. This one is also not significant, not significant. These are just placeholders. Now, we get to a 1. Well, if we're bothering to tell you it's a 1, it's significant. So that one's significant. If we know this one's significant, and we put a 0 there, that means we know that it's really a 0. It's really nothing. It's not a placeholder, it's nothing. Otherwise, we'd put another number in there. So that's significant. And we keep counting significant all the way through the rest of the number. Once you start counting a significant number, you have to keep saying that the rest of them are significant. Only before then can you have numbers that are not significant. So in 101,001,000, how many numbers are significant? 1, 2, 3, 4, 5, 6. This thing has 6 significant figures. That's the right rules. Let's talk about the left rules. The left rules apply when you have a decimal. So right rules, no decimal, whole numbers. Left rules, decimal. Now that doesn't mean that it has to be a number less than 1. It could be a decimal in the middle of the number. It doesn't matter. As long as you see a decimal, you have to use the left rules. In this case, you read from the left-hand end of the entire number and read right. The same rules apply. You don't start counting until you hit a 1 through 9, and then you count everybody after that. So let's look at this number, 0.001001, 0. Well, start reading all the way at the left-hand end. This number is a 0. We don't start counting until we get to something that's a 1 through 9. So that's not significant. Keep reading through the decimal. Still not a 1 through 9, still not a 1 through 9. Now we hit a 1 through 9. So that's significant. So that means that all the rest of them are also significant. So this number has 5 significant figures, called sig figs for short. As I said, just because the number has a decimal does not mean it has to be a number less than 1. We could have a number like this, 100.00101. For example, again, we're going to read from the left going to the right. The very first number we get to is a 1, therefore it's significant. Since the first number is significant, all of them are significant. 4, 5, 6, 7, 8. This number has 8 sig figs. So whether the decimal is at the beginning of the number or in the middle of the number, it doesn't matter as long as there is a decimal, we read from the left to the right. If there is not a decimal, we read from the right to the left. And then we don't count zeros until we get to numbers that are not 0. And then we keep counting whether it's a 0 or not. Okay, special rules. There are 2 special rules. 1, if a number has been counted and you need to be told this number was counted, it is infinitely significant. Meaning that it has an infinite number of sig figs. You can't say it has 1, it has 5, it has whatever. If I tell you that there are 28 books on the shelf, because I went over there and I counted all 28 of them, this does not have 2 sig figs, it has infinite sig figs. Because I know that it's not 28.1, it's not 28.2, it's not 28.5, it is 28.000000. I know all of those zeros are actually meaning zeros, not just placeholders, so this is infinitely significant. But again, you have to be told it's counted. If you just look at a number that has been measured, not infinitely significant. Got to be counted. Numbers in scientific notation. 1.20 times 10 to the negative 3. When you are dealing with numbers in scientific notation, you only care about this part of the number, which is called either the coefficient or the mantissa. Mantissa is kind of an older word. Oops. Mantissa. I do not count any numbers in the 10. I don't count any numbers in the exponent. It's only the numbers in the coefficient or the mantissa. So in this case, it's got a decimal, which pretty much all of your scientific notation numbers will have. Therefore, I read it from the left, going right. A 1 significant, therefore the 2 and the 0 are also significant. So this number has 3 significant figures. All right, so let's practice counting some significant figures in these numbers. Here's a number, it's negative. Oh, whoa, it doesn't matter. Whether it's negative or positive has no effect on significance. It's only about the zeros and the decimal places. This number's in scientific notation. We don't care about that. It's an important part of the number, but it's not important as far as significant figures. So, it has a decimal. That means, read it from the left. The 1 counts, so that everybody counts, including that 0. So this number has 5 significant figures. Sig figs. Next number, no decimal. Therefore, we're going to read it from the right. Starting here. No, 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 yes, yes. There's only 2 significant figures in this number. Okay? Try the next one on your own. I'll give you 2 seconds, and then I'll tell you the answer. Which way are we going to read this? Does it have a decimal? Yes, it has a decimal. Therefore, we're going to read it from the left. The 1 is significant, which means everybody's significant. This number also has 5 significant figures. All right, take a couple seconds and try this one. Hopefully you came up with the number 4. It also has a decimal. We're going to read from the left, but these zeros don't count. They're just placeholders, pushing that 9 back farther and farther into the decimal. Once we get to the 9, we start counting, and those zeros will also count, and then the 1 at the end. So this one has 4 sig figs. All right, to prepare for class tomorrow, I want you to make up your own numbers, but you have to follow certain rules. 2 numbers. First, I want a number greater than 1. So like this or like this. It has to have 7 significant figures. And it must contain at least one zero. Because of course it's easy if there's no zeros in there, those are all significant. But I want your number to contain at least one zero, and the number itself has to be greater than number 1. The second number I want you to make is a number that is between 0 and 1, so it's a decimal number, like this one.
Okay.
It needs to contain 3 significant figures, and again, it has to contain at least 1 0. You can have more than 1 0 if you want, but it has to have at least 1 0. Bring those numbers to class with you next class, and with your partner, check each other to see if you created decent numbers. Everybody's going to have different numbers, but have your partner look at yours and say whether it has 7 sig figs or 3 sig figs, and you check out theirs. And then if you have a problem, you can ask me whether